Welcome. We'll be talking about best practices and around salt states and salt formulas. My name is Seth House. I work for SaltStack. I've been there for a while. I've worn a variety of hats. Let's see. I'd like to get a sense from the room about how familiar with writing salt states, even salt formulas, everybody is. So quick show of hands, how many people have written basic states? Okay. How many people have written complex states? How many people have worked on or contributed to any of the formulas? Good deal. Thanks for that. So we'll be talking about best practices, gotchas, things to watch out for. And how to reason about states from a high level. Everything that we talk about today is going to be applicable to states that you have in your company or formulas that are intended for general use. The best practices between them are the same. So the public formulas on the GitHub, the SaltStack Formulas GitHub organization, they are structured in roughly the same way you should structure your states at your office, with the notable difference that they are written to a broad audience, right, across a variety of operating systems. And so that's where the map file thing that you guys have seen comes into play. I don't think that's me. So, for the map file, for example, for a broad audience, you're going to support a variety of operating systems, Linuxes and whatever else, and the BSDs and that sort of thing. And you're not likely to see that kind of variety at your workplace. Maybe you are, but it's the same principle. And so we'll go over that. So just keep that in mind that it's applicable to both. I'm going to be doing a bit of, I don't know if live coding is the right word, but I'll be kind of exploring the concepts we're talking about at the terminal, so hopefully that'll be viewable. So we're going to start by talking about writing. I should preface this by saying we're going to be going into detail talking about some things that are encoded in the docs. They're not always easy to get to. If you ever need a refresher on any of the things that we've talked about, of course, the video will be available. But there's a good document in buried in the SaltStack docs. It is linked to from all of the formula repos. It's the formula guide, right? And if you scroll down about halfway through that, it'll talk about just writing states. Writing states for formulas, of course, in that context. But as we just discussed, that's the same pattern that I would recommend in your workplace. So if you ever need those docs, find a formula, click on that link, and drill down from there. So let's kick things off with style. You guys have probably seen a variety of syntaxes for writing salt states, right? Sometimes they've got the function.module. Sometimes they've got something that's just the module, and then the function is a list item, that sort of thing. I'll show you what I mean. But these kinds of things are not, what we're talking about is style, right? It's not enforced. Salt is pretty unopinionated in how you structure formulas. And so this is a recommendation. This is something that we do try to enforce in the formulas organization, but it's just a good practice so that states, formulas, that sort of thing look homogeneous, if they come from a formulas organization, or if you're writing them, or if one of your teammates is writing them, for example. So what I'm getting at is, let's talk about something like this. I'm going to simplify this for a moment. All hard code Red Hat family defaults. So this is an example of a pretty simple two salt states. Quick bit of nomenclature. We're in an SLS file. There are two states in this SLS file, right? Two function calls. We're calling package.installed. We're calling service.running. Both of those are function calls. I'm going to harp on that point a little bit, but bear with me. So this is the common format you'll see across formulas, right? I imagine a lot of you have seen something like this, especially if you've been around for a while. This is a pattern that we're trying to get away from. Installed, right? So that is valid, and that exists for historical reasons. But this package.installed reads better, right? It's the same format that you'll see in the rest of Salt. It's the same format that you'll see in the Python path to the module. All of these functions that we're calling are Python modules, of course. So package.installed, it just reads better. You can also do something like this, right? You can do HTTPD. So I'm sure you guys have seen that, or perhaps that. So all of these are valid. But from a style point of view, we recommend that top one. And the reason for that is it, first of all, it reads nicely. You've got that top level state ID, right? So another bit of nomenclature. This top level, that is the state ID. This has to be unique across your state run, as you guys are, I'm sure, familiar with. And on top of that, it should serve as an identifier, right? It should explain what the state does. Tersely, of course. You don't have to be terse. It's a dictionary key. I'll harp on states being data structures throughout this presentation. But that's a dictionary key. So anything that's valid within a dictionary key is valid as a state ID. So you can put spaces, capitals, punctuation in there, that sort of thing. Ryan Lane from Lyft, he's a big fan of making these into full sentences. Install Apache and start the service kind of thing, right? So it just reads nicely. That's a little verbose for me. Plus, the most important thing is I can't autocomplete that in Vim, but I can this. So it should describe what the state is doing. And that's important for readability for as you're looking at state returns, that sort of thing. They're going to be grouped under this, and so it's a nice, just kind of quick identifier. You can group more than one state under a single ID, as I have here, right? That's totally valid. This is when you do this, I would suggest doing this for a reason, right? These two states are always going to be run together. These two states are always going to be reasoned about by a single thing. I'm going to always do these in pairs. And so maybe this is not the best example for that kind of thing, right? I can foresee wanting to install Apache on a system but not start the service if I need Apache installed for a development library if I'm compiling against it or something like that on a build server that's not running the Apache server but needs Apache installed. And so for that instance, I might separate those two states. But if I'm building out web servers or something like that, then group them, but do so on purpose, specific for your use case. In the case of a formula, since it is general purpose, I would definitely recommend breaking this into two, right? Something like that, so that they can be referred to individually. Let's see. So use the module.function notation. It reads well. Use the name parameter, as I mentioned, it's optional, right? We can leave that out for those old historical formats that we see at the bottom there. The reason name is a good thing to just get into the habit of using all the time. Is the thing that is in name, right? The value you put under name is almost always, the way we've structured salt states is almost always the thing that varies by platform, right? It's a directory or it's a package name or something like that. So if you're installing across multiple distros and you change that, now you've got to change requisites that point to that across the whole place. Whereas if you get into the habit of using name, specifying this identifier, this unique identifier, that identifier becomes pretty generic. You just refer to it from wherever, and you get that one reference to it. So let me show you what I mean. Say we want to ensure that the service starts before the package. We don't need to put in a requisite here since Salt does source order execution, but let's do it anyway. So install Apache, right? So if I had done something like this, valid, it's a nice shorthand for sure. But now I've got to deploy against Debian systems as well. So I have to update this, right? And now my requisite also needs to change. So now I've got to put these in a for loop or something like that. Whereas if you keep it generic by putting that value that changes within the name parameter, that makes your state more bulletproof, right? More resistant to change, alterations over time, right? That's the constant. You're going to write this once, and you're going to evolve these states, over the course of whatever you're managing with them. So comment your states. Obvious suggestion, of course, but it's unusual syntax if you're just coming into Salt. So get into the habit of it, and you can use YAML style comments. Oops, there we go. I didn't undo one level far enough. So install the Apache package, right? Use YAML style comments. Okay? You can get pretty granular here. You can use multiple paragraphs. If you want to do something like this. Maybe format it nicely. So as I mentioned, we don't need a requisite here. You guys know that salt, by default, executes in source order. So it hits that one at the top, and it moves on to the other. But if you throw this file, we've got this one Apache file. If you include that into another SLS file, then ordering becomes a lot less predictable, right? Especially source order execution. That's where you really want to lean on requisites to enforce that ordering. We'll talk about ordering a little bit, but the short version is source order execution is nice when you're in the context of one file or maybe two files. But as soon as you've got a state tree and you're including SLS files between each other, you really want requisites. Requisites are the final word in salt state ordering. And so if this is included in, say, your build server's SLS file, then you're going to want to specify that and make that explicit. So the comments can go anywhere. There's one thing to watch out for, and we'll talk at length about this, but if I were to put Jinja in here, oops, and run. That's going to run. It's in a comment, but that's going to run, right? Jinja and YAML are completely separate things. We'll talk about that next, actually. But use comments. All right, let's talk about Jinja. So Jinja is very powerful. Thank you for mentioning that. The way to guard this against Jinja is to use a Jinja comment. I'll update this example in just a moment, thanks. Jinja is very, very powerful. It makes states completely open-ended. You can do anything in Jinja because Jinja has access to, in this example here, salt, all of the salt execution modules. The syntax is different if you're not familiar, right? If you run salt star something, on the CLI, that is this. We're calling the same functions. One of the milestones you have to get past, we're talking, you guys are a pretty advanced audience, but just in case, one of the milestones you have to get past when you're getting up to speed with salt is recognizing what it's doing under the covers, because once you get over that milestone, it's very easy to reason about what salt is doing. It's just calling functions. Just Python functions. It's ridiculous and obvious, but until you get over that hump, it's not obvious. And so salt's got this collection of modules. It's huge, right? This page just goes on and on and on, right? All of the execution modules, of course, are under the M index. And so of everything in this page, the stuff that you call from the CLI is just this subset. And this definitely isn't this class, but when you type in salt star, command.run and then something, what salt does, what the salt CLI does is it takes what you've typed in there, it converts it into a little Python dictionary containing all of those things that you just typed in, right? It contains the target, which is star, the default target type, which is glob, unless you change it, right, with a flag. It takes it's got a dictionary key called fun, right? And it says that command.run. And then if you pass in any arguments, like you would with command.run, it puts that in an arg field. So it's a tiny little dictionary, and it ships that over the wire, so it gives it to the minion. The minion decides whether or not it matches that target. You guys should know all of this, right? But then what it does is it takes that dictionary, if it matches, right? If it knows that it's supposed to execute that function, it takes that little dictionary and it just maps it to a function call. We've got this utility function in Salt that we call everywhere. And it takes a dictionary and it introspects a function using the Python inspect module to get that arg spec, right? It looks at the function saying, this is the name of the function, these are the arguments this function takes, and it takes this dictionary and it just overlays it to it, figures out how to call that function with the data in that dictionary. So this is very important in the context of salt states because salt states are dictionaries, they're data structures. That's what you're doing when you're building a state. This is, again, something that's not obvious. The YAML syntax, it reads nicely, very terse, very top to bottom. But what you're doing, you as an SLS author, your goal is to build out this data structure that is used to call functions in a particular order, right? The functions aren't context aware. There's no magic happening behind the scenes. If you do something like this, we're building up two dictionaries inside of a bigger dictionary, and the top one says, call the package.installed function with this parameter, name, right? And then the other one says, call the service.running function with name, right? It special cases a couple of things like requisites. Let's pull up the salt state. So these are execution modules. One of the things that, as I mentioned, once you get over that hump of knowing what Salt is doing under the covers, usually, once you know how Salt works, usually then the only complex thing is figuring out which modules to call and where to do the thing that you need to do, right? Installing a package right now or enforcing that a package is installed over time. That's the difference between an execution module and a state module. And so usually when you get over that hump, you want the API docs and nothing else. You know how Salt works. There's not a lot there, but it does take a little getting up to speed with. And after that, you got to figure out how to call all of these hundreds of functions, thousands of functions actually across hundreds of files in Salt. So let's take a look at the package function, the state function. One of the things I'll try to do is always qualify when I say a module in Salt with what kind of module it is. It's a state module, it's an execution module, it's an auth module, it's a file server module, that sort of thing. So we're looking at the package state module, not to be confused with the package execution module. They do share the same name. They have an implicit relationship, but they don't have an explicit relationship. So what we're doing here is we're calling the package.installed function, right? So when you write states, hopefully you guys already do this pattern. When you write states, you pull up the docs, you look at the function signature at the top there, or maybe you look at the parameters, the human-friendly parameters, and you figure out this is a function, right? Somewhere in Salt, there is a Python file called pkg.py, and inside of that file, there's a function, def installed, and that function is this, right? That is the function signature. And you can see that that function signature takes a first parameter called name. If you've never noticed that, that is exactly why all of the Salt states take that name in the YAML, right? Because you're calling this function with a dictionary. And all Salt states have that convention that they take name as the first parameter. What they do with name is pretty open-ended, but they all take that parameter. And so that's why that's in that dictionary. So we're mapping that dictionary onto this function call. It seems like an obvious thing, but the reason I'm harping on it is it's important to keep that in mind as your end goal, to build up that data structure. You're not writing a shell script, right? You're not writing something that's going to execute sequentially from top to bottom. If you throw requisites into the mix, if you throw includes, that sort of thing, some of the crazier requisites like prereq, for example, can do some pretty complicated things pretty tersely. But you're building up this data structure in a particular format so that you can hand it off to Salt's state compiler and it can do its thing, calling these functions in the right order. So it calls package.installed, and then it moves on to calling service.running. It doesn't remember, or it keeps track of what it's run, but it doesn't pass anything from one to the other. Each one is just a plain old function call. So that's nice in that it's very simple, but you as state authors need to keep that in mind. You are building a data structure, and so, back to Jinja, know the render pipes order of things, right? This is something you can specify in the top of your SLS file. It's optional, so not everybody has seen it. But if you've ever seen that shebang syntax at the top of an SLS file that lets you override which renderer you're using in Salt, the default is Jinja to YAML. And that pipe syntax, I like it because it's indicative of how it works at the shell. Do this thing in Jinja. When that's done, pass the result off to the YAML module. So back to, I should say, renderer module. So back to modules. So here's the module index. These are, of course, renderer modules. Hopefully you guys have seen, you're at least topically familiar with these. Salt ships with a lot of modules. There's a Python module, Jinja module, YAML module. And each one of these renderer modules does something slightly different depending on its context, right? The goal of the YAML renderer module is to take something, right, a file off of disk, parse it as YAML, and return you, whatever the result of that is. So, probably a data structure. The goal of the Ginger renderer is to take something off disk, probably a template file, run that through the Ginger interpreter, and give you whatever the result of that. And in Ginger's case, since it's a templating engine, the result is a string. So it takes something, runs it through Ginger, producing a string, runs that string through YAML, producing a data structure, gives that data structure to SaltStack compiler. SaltStack compiler does a few checks, hands it off to, and then starts calling functions, right? Sequentially, one after the other. And so this goal is important because not only are you the author of this managing, this is not something, I should preface this whole thing by saying, this is not something beginning users need to worry about. It's easy to write salt states, but since this is an advanced class, since you guys have done this, it's important to keep that in mind, keep that goal in mind, so that when you run into things like putting Ginger inside of YAML comments, you know exactly why that didn't work, right? Ginger ran first. It doesn't know anything about YAML. And so it kicked off that shell function, and we didn't want it to. So instead of using a YAML comment, we should use a Ginger comment. Oop. Not quite. There we go. So now it doesn't get run. But Ginger runs up front, hands it off to YAML, hands it off to SaltStack compiler. This also becomes important for ordering, which we'll talk about as well. All right. Keep in mind, anything you do in Ginger bypasses SaltStack compiler, right? It's not, as I mentioned, the result of that render pipe is building a data structure to give to SaltStack compiler that handles all of the normal things. And all of SaltStack functions, they are the idempotent thing in Salt, right? Package.installed, the function. It goes through the procedure of looking to see, okay, I'm being asked to install Apache. Is Apache already installed, yes or no? Yes, there's nothing to do, right? We bail out, no changes to the system, that's it. But Ginger happens way before that process, right? The render pipe process. And so anything you change on the system via Ginger bypasses test equals true, bypasses that idempotent check. And so usually the thing you should do with Ginger is to inspect the system, right? What OS am I running on, so that I can choose which package name to install, that sort of thing. So keep that in mind, that Ginger should just be used to inspect the system and not change the system. Also, separate logic from states. This is a hard thing to do, but a wonderful thing to strive for. So let's see. I'm sure you guys have seen states where you've got for loops embedded inside of the state. So you've got for package name in a list of supported OSs. Kind of thing, right? Does that look familiar to anybody? It's a common thing to do. And it's easy, right? It's fast. But it's something to avoid. It's something to strive for avoiding. Putting logic, putting any kind of conditionals or looping within your state makes it, well, for one, harder to read, right? I've got a development background before I came to Salt. I did a ton of Django. I'm intimately familiar with this syntax, the Ginger syntax, the Django templating syntax. And I can't read, right? I can't read this. If it gets in any way complicated at all, I can't read it. It's just too much visual noise. So try and avoid this, right? Sometimes you can't. Sometimes you definitely can't. But if you can, say, wrap the state as a whole inside of the loop, now the state becomes easy to read, and the logic surrounding it is boilerplate. Not boilerplate, but extra information on the outside of it. So even that stupid little change makes the state readable, solves a bunch of weird YAML, indenting problems, like, it's hard to eyeball when something's wrapped in a Ginger for loop if it's indented 3 spaces or 2, and so, YAML's gonna throw an error, that sort of thing. So little things like that aid in readability. The other thing to do is the map file construct, which you're familiar with if you've seen formulas. We'll talk about it in detail it also allows you to do this kind of thing. So you need to pull the name of a package for this the system from a map file or from Pillar or from wherever. Now you're just referencing the variable name, so you don't need the for loop. The state itself doesn't need to change. Let's see. If you need to do, if you need to set a variable, set a Jinja variable, set current user, solve that command.run, right? Who am I, kind of thing. Set that variable away from the state, and then reference it inside of the state. This isn't a great example for that, but say we were doing something with current user in here. Separate those two. If anybody has done anything with PHP, going back years, embedding the two, embedding the Jinja with the state has all of the hallmarks of all of the bad things people didn't like about the early days of PHP, where you've got the HTML and the PHP just completely intermixed. So, all right. Moving on. As I mentioned, good uses, inspect the local system, gather external data, right? And the nice thing about this is it doesn't matter where you gather the data from. Your goal is to build this data structure, right? You don't care where the data that informs what this data structure looks like comes from, right? It can come from Pillar. It can come from another file on the file system, a map file, right? That is that pattern. It can come from shelling out and inspecting things. So those are all great uses of Jinja. Light conditionals, light looping. As soon as that gets complex, that is a code smell. That is an SLS file smell, right? That is an indication that maybe you should be moving that logic somewhere else. Maybe it's an execution module. Maybe it's into a map file, something like that. And call execution modules, right? Execution modules are sort of the utility library of Salt. They do all sorts of things, right? Everything you can do on the CLI. A lot of them are special cased for, they're intended for use from within states. Some of them are intended for use within SLS files, right? If you guys have ever seen the filter by functions, we'll talk about those in a bit. Those filter by functions are execution modules intended for use within Jinja. Less good use, as in definitely avoid these things. Don't intermix, and okay, let's talk about Jinja macros briefly. It's tempting to think of Jinja macros as a function call, right? Because it looks like a function call. You call it with parentheses. It's not. It's a mini template. Macros do have a place in salt states, but think of them as mini templates from within the template, right? When you're writing an SLS file, you are templating. It is a Jinja templating language, right? Think of them as mini templates to repeat something, right? Maybe it's a good use to programmatically generate a single SLS, or excuse me, a single state call within an SLS file. Something you have to do over and over and over. Call the same function with different parameters, that sort of thing. That's a good use of a macro. But don't use it as a function call. If you start making a macro and you've got a bunch of if conditionals in there, and you're trying to build up a dictionary by declaring the dictionary outside of the loop and looping over something and adding it to the dictionary on each pass, that's a good indication that maybe you should just make an execution module, a utility execution module. If you haven't done it, it is a 5-minute process the first time you do it. The 5th time you do it, it's a 30-second process. You just toss a Python file with a function in it in your serve salt_modules directory, sync it down to the minion, and you're done. You can call it from states. So use execution modules, write execution modules with complex logic, and call them from states. All right, map files. You're definitely accustomed to these if you've done any work with formulas. The goal of a map file is to get rid of conditionals, right? The goal of a map file is to have one place where you can see a bunch of differences between who cares what, and say, I care about this subset of the stuff in this list of things. I'm building this SLS file up on a minion, right? As you guys know, the SLS files are compiled on the minion. You send out that execution to all of the minions. They pull the SLS files down from the master, and they run that compilation process locally, building up that data structure locally. So all of the execution modules that you call, all of the grains that you reference, is all being referenced locally there on that minion. And so, if that's running on a CentOS minion, you don't care about all of the Ubuntu stuff. And so that's what a map file does. You just say, I care about this subset of the dictionary. Let's pull one up real quick. the Apache formula. So you guys have seen this pattern, right? There we've got Debian and Red Hat. And so they're right next to each other. So the nice thing about putting these in a single place is, say I want to add support for one of the BSDs, I can see all of the data points that I need to add in order to make that BSD support first class, along with Debian and Red Hat. But the purpose of this map file, when compiled, is saying, if you're on a Debian server, I just care about this tiny little dictionary inside of this big dictionary. And so that is what that grains.filterBy function is, right? Have you guys ever looked into the details on this? It's just an execution module. Let's pull it up. So modules, grains. And so that's it. It's a function that takes a dictionary and a grain, and then it looks that grain up in the dictionary. It just filters that dictionary by a subset. So this is a powerful construct for getting rid of logic in your templating language. You're just fetching the subset of the dictionary. So it's obviously useful for abstracting out platform differences. That's the go-to. That's what most of these map files and formulas are used for. But it can be used for anything, right? Any common data that varies by whatever, by environment, by user, by whatever, right? If you've got some data that has that kind of central thing that you can look it up by, then it's a good candidate for a dictionary or for a map file. And so write them, use them. You don't have to use filter by. It's doing nothing. Look at the code. It's 20 lines of checking for edge cases. It's just doing a dictionary lookup. So make your own and do your own dictionary lookup. If you do, allow it to be overridden. This is important, right? This is what makes map files, these lookup dictionaries, extensible, right? There's always going to be some stupid edge case, some legacy server under somebody's desk that nobody can turn off because nobody understands how it works, and you got to special case it. And so allow pillar is the common go-to to override that. So you've got this SLS or this map file that you ship with your states, but then you've got this one special case in pillar with that minion ID, that snowflake, that pain in the butt server, his ID, and then that same dictionary, and then that dictionary just gets overlaid on top of whatever subset you pull out of the map file, and poof. You now can reuse that same SLS file for all of your infrastructure and the stupid snowflake without changing the SLS file. So. Good to differentiate dev from prod, as it says. Also just saying defaults, right? Say you've got an application that you're using an SLS file to deploy new versions of your application. The same default might be, the master branch or, the path to the Git repository, that sort of thing. And then if you ever need that to vary, you just override it with pillar as well. So anything that can go in there. I should have referenced this beforehand. What time do we quit? Anybody remember? Say again? I think it's 2:30. Thanks. All right, we're doing good. The filter by functions, they do a few things, as I mentioned, right? They grab that subset. They allow you to override via some external data source, usually pillar, but not always. Another good construct is to say these are my defaults, right? If you've got some data points that vary between servers, but for the most part they reuse the same, make a single dictionary. Say this is the default. This is everything. Everybody's going to share most of this. And then just override the parts that you care about. So look at, pull these functions up. This class is definitely not a substitute for getting your hands dirty, jump into the docs, read through these. So look at the defaults parameter, right? It's one of the lesser known parameters of the filter by function, but it's important. And it allows you to make very terse states. Again, no logic, and it allows you to do pretty complex dictionary lookups, producing a single dictionary, which you use to render your state. Let's see, there's been a few new additions. They're in the develop branch, so they'll be cut with the new release. I don't think they made the cut for the one that just got cut, whose name I'm blanking on, 2015. 2016.3. Thank you, 2016.3. So they'll be in the next release. But SLS util It's an execution module specifically for helping SLS files out, right? So it's got merge, it's got update. These are functions that do recursive merges in a dictionary, right? If you're a Python programmer, you know if you've got one dictionary and you've got another dictionary and they've got the same key, the same top-level key, you do a dictionary.update with the other dictionary and it overrides that key. So all of the contents are lost. Versus a recursive merge where it says, you know, oh, these keys overlap, so I'm going to combine their children instead of just overriding. So we use these in Salt all over the place, these recursive merges, right? Whenever you build up a state tree in an SLS file run, we do these recursive merges. You know, if you've got a list of things, we append to that, or if you've got a list of requisites, we append to that list of requisites rather than overriding your requisites when we merge states, for example. So these two functions expose those recursive merges in Salt. There's another filter by function which is not very well known. It's in the match module. This is a good one to use in Pillar. Oh, by the way, Pillar, state files, and Orchestrate, they all use Salt's state system, right? They all use all of these same mechanisms. You can call out to execution modules. You can reference grains. You can do all of these things from any one of those contexts. So keep that in mind. Orchestrate, this is not this talk, but Orchestrate is a powerful thing because if you think of it from the context of it's a master-side state run, it's doing all of the same things. It's got access to all of the same functions, execution modules, state functions that a minion does, but just in the context of a master. So now it can do crazy things like call out to a minion, wait for that minion to finish, and then call out to another minion. Orchestrate is very powerful. You don't have to use it to call out to minions. You can just use it to configure the local master, right? Kick off an Orchestrate run that does nothing but change the master. And not having to context switch between different syntaxes or something is another huge benefit of Orchestrate. So let's talk about the match execution module. It's got a filter by function, filter by. And this is very, very useful from the context of Pillar, right? So here's an example of what I'm talking about. Have you ever had an instance where in Pillar you wanted to do something like you wanted to pull in some data points from some common place and apply it to this group of minions, right? That is a map file. You can use map files in Pillar. There's no difference. You're doing the same thing, building up that dictionary. So, for example, the match module, incidentally, is what Salt uses for its matching logic. Salt makes this kind of a habit of exposing things that it uses internally, externally via execution modules. So if you've ever wondered, when you type in salt web star test.ping and hit enter, how the minion figures out if it matches that web star, it calls the glob function in this module. That's it. You can call it yourself. So that's what this filter by is doing, right? It's saying, I'm generating Pillar for a minion who has the hostname web1. And so I'm going to run this filter by function against that cached grain data. And so it matches that top level key and it says, okay, so I see that guy has the following roles, web and caching. Map files from within Pillar. Let's see. One other one, we don't have a lot of time, so I'm not going to spend a lot of time talking about it, but SLSutil.renderer. One of the problems with map files, if you've worked with them, you've probably been annoyed by this, is they're pretty Jinja specific. They're using Jinja syntax. They're written in Jinja. It's usually map.jinja. That's the pattern. I'm kicking myself for not realizing that would be kind of a pain in the butt and realizing that I could just use SaltStack system for the map files. So it's a late addition, but there it is. What this lets you do is this lets you write a map file using any one of Salt's supported renderers. So if you want to write a map file in Python, you write a map file in Python. If you want to write it in Jinja, you write it in Jinja. And you can import it from anything else. So one of the problems with map files is you write it in Jinja, you can only import it from Jinja. But with this in place, you can write it in Python, import it from Jinja. You can write it in Jinja, import it from Python, that sort of thing. So that's in the docs. I wish I had more time to pull up an example. All right, let's talk about how to reuse SLS files. Because these are the things that take a long time to write. The syntax is simple. Installing Apache you can crank out in a minute or two. But installing Apache, getting that in the right order in the context of a broad state run, it's doing hundreds of things on a system, a full high state run, that takes a while to build out. And so the more you can reuse those, the more you can have little silos of tested, baked functionality, the better. So each SLS file should do one thing and do it well. There should be one SLS file that installs Apache and starts the service. There should be one SLS file that puts the configuration file in place. The reason for this is, it sounds terribly granular, but the reason for this is now I can import these files from other SLS files. So say I've got PHP, for example, that is in its own SLS file. This is why the formula organizations have these small SLS files. Say I've got the PHP formula, and it needs to ensure that it gets installed after Apache, right? Now I can just include that one Apache file, and I don't have to pull in all of the other stuff that would come along with that, right? I don't care about putting the Apache's configuration file in place. I just want to make sure that the service is started. So just include that one thing. So yeah, adhere to that function, that programmer ideal of a function. That function should do one thing and do it well, the Unix philosophy. This also allows mixing and matching, right? So now you've got this SLS file that does one very specific thing. It's easy to test, it's easy to reason about in isolation, and now you can call that from anywhere, right? You can call that on the CLI, state.sls, just that SLS file to do just that one thing. You can call it from high state, just by including it, or putting it in your top file. You can call it from orchestrate, right? You can say, do this SLS file on a minion, right? And then do some other things, and then do this other thing back on that same minion. It lets you break up a state run via orchestrate into calling a bunch of SLS files. And of course, you can call it from the reactor, which is quite nice. So again, beyond the scope of this talk, but one of the goals of the reactor is to be very, very simple. A reactor is see an event, call a function. And so the thing that it calls should be something that works in isolation. And so if you package that up into an SLS file that does one thing, now you can just call that from the reactor, and you don't have to test it because, well, you don't have to test it much because it's only doing that one thing, right? The reactor just calls that thing that you've already called from the CLI 1,000 times. Parameterize argument names, as we did with the name parameter. Do that everywhere, right? Anytime you see value changing, between environments, between operating systems, toss in a Jinja variable so that you can parameterize it, so that you can override it from Jinja. All right. Let's see. Know that you can override SLS files with that shebang syntax. So say I am doing something complex, and I decide that YAML in Jinja is just not the right thing for that. I can write an SLS file as simple as that, right? My SLS file is now using raw Python. And again, we're just building up a data structure. So the only thing this function needs to return is a dictionary. And if you ever need to know what that data structure looks like, type it out in YAML here, right? Install Apache, package dot installed, name, HTTPD. That's the data structure that you need. Just find something that can translate YAML for you. YAML is wonderfully readable, but it's not always obvious that it's a data structure. So just run it through something like that, right? That's all your Python function needs to return, is that dictionary. On that note, Salt doesn't care where that dictionary comes from, right? If you want to do crazy things like calling into a database to build up this dictionary, do it, right? There's no reason you have to use Jinja. Jinja is just an SLS file generator. So any way you want to go about that is fair game. This is pretty obvious. Group-related files within the same directory. So all of the Apache files should go into an Apache directory. All of the Apache configuration files should probably go into a conf directory. This is going to vary from place to place, but just keep your directories shallow, and chances are you'll be all right. OK, we're almost out of time. Let's talk about testing formulas. So we've got a follow-up talk to this tomorrow that I'm participating in to talk about some thoughts and some recent additions to Salt that help this front. So feel free to join that if you're interested. So know the order that things get executed in, right? Jinja to YAML, off to Salt State Compiler. Salt State Compiler translates that dictionary into a list of dictionaries and starts executing on them in order. We don't have a ton of time to go into the details on that, but that's an important thing to know, right? It hits package.installed, it moves on to service.running, it moves on to whatever, right? Any requisites that it encounters, it will then pause and do its thing. But that state compiler is just calling those function calls. And when it does that, it calls package.installed. Package.installed returns something. You guys have seen it before. Even if it's not obvious, it's a dictionary. I'll show you in a moment. And it puts that into what we call the running dictionary. And so then it moves on to service.running, right, as we have here, as we had here. So it moves on to service.running, and service.running has a requisite. Had a requisite saying that package.installed has to be, or the Apache package has to have been run first. The way it checks that is it just looks it up in the running dictionary. It says, do I already have a value for this in the running dictionary? If yes, then the requisite is resolved. If not, it pauses, it runs that thing, and then it comes back. It's just a recursive function call. Let's see. I was going somewhere with that. So the running dictionary is that running tally of what's happened in your state run. And you guys have all seen it, even if you didn't know. It is the return from running state.sls or state.highstate. That structured output for each one of the states, that is the running dictionary. If you look at that in JSON format, it's a dictionary. And so that is the final word on state ordering. So this is an important thing. Let's see. Let me jump back to. Right? Say we've got something like this. So show SLS file, or the function, hopefully you guys are familiar with it. It shows you that data structure. It shows you that data structure that you're building up. If you need, if you want to see that laid bare, right, output it as JSON. And so you can look at it, right? Here's the execution, or the source order in the file, right? So it does the one and does the other. JSON is unordered, of course, so we're looking at it backward, but Salt keeps track of where it shows up in the file, which is why there's this order thing. And so when it runs it, it puts it into that running dictionary in the order that it was actually executed. So this is a really nice thing to be able to test what order things actually ran or actually would have run. So let's run state.sls for real, and let's do test equals true, okay? And I'm going to output that as JSON again. So this is going to be kind of weird because I'm running it on a Mac. But this is the running dictionary, right? There's our traceback from Bro saying, wait, what? But you can see package.install, that top level key, that is package.install. That's how Salt knows how to look up that state uniquely in this running dictionary. And you can see the run num, 0, that is the state that was run first. So if you're ever debugging ordering issues, run it in test equals true mode. And look at that order. You guys have all seen this output. It'll be a bit red, but there you go. You guys have all seen this output. This is the definitive order, right? It did this one thing, and then it moved on to the next thing. So that's a wonderful way to debug ordering issues. Kick it out in dry run mode, and look at the running dictionary. This is that running dictionary. Let's see. And on that note, what are you testing for at any given point, right? This is important. There's a lot of layers in this system. So, run show SLS to suss out any Jinja syntax errors or any YAML syntax errors. Once you're done with that, it'll hand it off to Salt State Compiler. Salt State Compiler does a few pre-checks, looking for duplicate IDs, recursive requisites, that sort of thing. And so that'll show you any syntax errors you have in that high state structure that you're building up. And so that's important. When those error messages come back, when you run state.sls or state.sls, if you're actually kicking it off, look to see where that error message is coming from. Is it a YAML error? Is it a Jinja error? Is it a Salt error, right? Because of that layered execution. Make sure that it ran or is going to run in the order that you expect by looking at that running dictionary that we were just talking about. And then use requisites. Use the on-changes requisite, the on-fail requisite to model failures or changes or mitigation, right? Use the on-fail requisite to take some recovery action if a state that is important fails, right? If you're trying to deploy a new version of your application and it fails, the Git server can't be reached, so it can't pull down the new version of the app or something, you might want to recover with an on-fail requisite and put that most previous version back into place or something like that. So model those failures and use the running dictionary to do that, to see that ordering. And we'll have more on that with recent additions in Salt, namely mock runs, if you've seen that as well. And then verify the result, right? After you kick off a state run it again with test equals true mode just to make sure that there's no changes to the system, right? Have Salt check itself. And then last, two ways to provide preconditions. One is a lesser-known function called checkPillar. It's in the test state module. This is a nice thing to ensure that you've got certain pillar values available before you kick off a state run. So states.test. A lot of the things in this module are just for mocking out state runs that return dummy data. But checkPillar is a really useful thing. So check that this is present. Check that this is an integer. And if any of these things fail, bail out, right? Use the fail hard option. If you guys are familiar with the fail hard option, that tells Salt to don't continue the state run after this failure. Fail hard here and just show me the output. So this is a nice way to check up front that you've got all of the pillar values or whatever you need to complete a state run. If you ever need to do something that this doesn't satisfy, then a really simple way to do something is to do some check, shell out, something like that, and then explicitly make a Jinja error, right? If I were to do something like this, there is no Jinja tag called state, and so that'll fail immediately since Jinja happens at the top. No salt states will have been executed at this point. And the error will be right there in the Jinja error. There is no thing called state failed, and you can see it. So it's kind of a silly workaround, but it's a nice thing if you just absolutely need to bail out of that Jinja process. So that's it. Thanks. I want to tat over. I'm available for questions afterward.